Thank you guys for coming. So nice to meet everyone. Raise your hand if you use PyTorch. Great. And raise your hand if you use Lightning with PyTorch. All right, love it. Raise your hand if you hate Lightning with PyTorch. Good. No one. Good. So we've done the thing now. Who uses TensorFlow? All right, we're gonna convince you to switch today for many reasons, which you'll understand if you try it out. Anyways, so I'm William Falcon, creator of PyTorch Lightning and CEO of LightningAI, and very excited today to share some of the things we've been working on and how to help you do more. So let's talk about open source first, right? This is kind of what everyone knows about Lightning today. So first off, PyTorch Lightning is by the company LightningAI. I know it's obvious, the name's there, but people are confused apparently. So just want to make sure that you guys know it's exactly the same thing. Same people, same everything. Everyone who's built all of this is at our company. Lightning today is downloaded roughly 66 million times in total. So roughly 4 million per month. This is over 10,000 companies across the world who use Lightning for production workloads, from training to fine-tuning to deploying models. And most companies today, a lot of them are switching out of TensorFlow into PyTorch, and they're doing it through Lightning, right? So they're not going directly to PyTorch first, and I'll explain why. GitHub stars, so you can see this kind of trend here, and we have some other repos that I'll show you. Those are fine, but I think the most important thing here is this use by number. So use by tells you how many repos in the open source use a project. You'll see that there are a lot of projects with like a lot of GitHub stars, but don't really have use by. That seems a little fishy to me, but you can't really fake 22,000 GitHub projects using your project out there, right? So these are across probably most companies, you'd find an example there. Close to 900 contributors. It's our team internally. Many people across, our team's only 40 people, by the way. So it's obviously not all of our people here. We have people from Meta, NVIDIA, Google, every top AI company collaborating in Lightning. So when you get TPU support through Lightning, you're actually getting it directly from Google through us, right? So we work with our engineers to make sure that TPUs will work super well on the infrastructure. Same thing with GPUs. So we work tightly with NVIDIA to make sure that these things run really, really fast. So this is one of the things you're getting through the platform. Anything that comes out that's new is going to land in Lightning within a few days. All right, who knows NeurIPS, big AI conference? All right, so NeurIPS is probably the top AI conference for research. So these guys are probably a year ahead of industry in terms of what's new, what's trending, what are the new papers that are going to come out. If you'd gone to NeurIPS, you would have seen Stable Diffusion probably a year before you saw Scalability AI, because it was something that was already out for a long time, right? So they have a challenge for training an LLM on one GPU. So if you want to train an LLM today, pre-train or fine-tune, you're going to need like thousands of GPUs and like millions of dollars to do this. So the AI community is coming together to do this challenge. And the code that they're using to do that is our code as a template, right? So if you see on the repo here, LitGPT, it's one of our models. It's actually the base model for this challenge. So everyone who's submitting all of their baselines and all the things that they're trying to do are going to be using Lightning under the hood. This is really important because for something like this, there's a ton of options today, right? That you could pick from models, different implementations, frameworks, and so on. But people like the simplicity that Lightning provides, the conciseness of the language and the expressibility of it, and the fact that it can scale. So I'm going to give you some examples of how Lightning gives you out-of-the-box optimizations. So in June 5, Falcon 40B came out. It's a model from the UAE. And sorry, probably like June 2nd, something like that. In June 5, we ported it to Lightning and made it 20% faster just by doing that, just by porting it over to Lightning. So if you're spending $1 million to train this model, we just save you $200,000 by doing nothing, right? So this was a few days effort. Here's some other examples. This is LitParrot, which is one of our other repos. Sorry, it's called LitGPT now. So any GPT-based model, you can use this repo to train. Anything that's GPT-based, right? So here, in this particular model, when Falcon 7B came out, if you were kind of training this model yourself, you're fine-tuning it, and you wanted to do 52,000 iterations, it would take you about 9 hours on 6 GPUs. Once we optimized it with Lightning, we basically got it down to about 1 hour on one GPU using some of these techniques that are there as well. Adapter 2, LoRa, and we have collaborations with all these labs. So when these techniques come out, they land in Lightning very quickly as well. So this is like real savings. We're talking 1/9 of the cost here, right? Actually, 9 times 6, right, of the cost. Great. Here's another thing that we did. So we have a PyTorch team internally. So I'm from Facebook AI Research before. It's where I was doing my PhD. And a lot of us actually come from Meta as well. So a lot of the people on our team were the original creators of PyTorch, so the core contributors to PyTorch. One of those is the head of the profiling team at Meta, who's now at Lightning. And he was the head of the profiling team at TensorFlow before. So when he joined our team, we started working on optimization of models, of pretty large models, and we noticed a pattern, right? So on the left, you see PyTorch, where it's the memory allocation that it takes for a model, right? The purple thing at the top is the backward pass. So when you're going on the backward pass, you're not releasing the memory. PyTorch doesn't release the memory. TensorFlow does. So he was like, wait, what's going on? So TensorFlow was more memory efficient. And he remembered this from working on TensorFlow. And so we found out that PyTorch is not releasing the backward pass. So it means that you needed 25% more memory. It means you need bigger, more expensive GPUs. We made a very quick fix, and it landed on Lightning, not PyTorch. So on Lightning now, if you're using it, you will actually save 25% memory from this thing specifically. This is not available in PyTorch, for example, right? So there are certain optimizations that land directly in Lightning as well, which is why going through Lightning, you're getting all of these things out of the box as well. This is Llama, so Llama 7B. So before, when you were basically trying to use this, time per second, I think this is iterations as well, to fine tune. So basically, it was about 40 seconds to do a few iterations. So it's like kind of the, forget the name for this, when the model's kind of like training, and the memory that you needed to load this model. So you needed about 30 gigabytes of memory. Once we, again, did some optimizations important to Lightning, we're using Fabric, which is a module within PyTorch Lightning that you can basically use to write your own trainers and have full control. Then we basically enabled half precision and a few other optimizations, and then we got it down to basically a few seconds of iteration and like 1/3 of the memory cost, right? So all these things add up. These are like 10, 100x speedups that you're going to get in models. These translate to real-time savings. So if you're trying to pre-train or fine-tune, these things get really expensive very quickly. Our whole job here is to make sure that you don't have to spend a lot of money doing these things. And also that you don't have to hire 20 engineers from Google and NVIDIA to do this for you, because you won't do that, right? So all of this lands on the open source for the benefit of the whole community as well. So TLDR, as a company, what we really do is optimize models end-to-end, right? And the way that we do this is we do it across the whole stack. That means that we do it at the infrastructure level through the enterprise platform. We set up all your clusters. We make sure they're super well networked, make sure the data can hit the machines really fast. One massive problem today in industry is how do you get the data to the machines to train really, really quickly? That's a huge problem, right? So how do we do that? Make sure it's not network bound, make sure the latency is good, blah, blah, blah. There's a ton of work there. You could have the best, fastest models with the best GPUs, with the best interconnects, and you're still going to be 1/10 of the speed that you should be because you're not loading the data correctly. We also allow you to run different accelerators, right? So Lightning was the first library ever to introduce the ability to run between GPUs and TPUs without changing your code whatsoever. Today, that's kind of the standard across other libraries. So if you ever use something called a trainer, right, from other libraries, this is something that Lightning created in the beginning, and then it was adopted across industry as a good standard. So we've been leading a lot of these developments from early days. On the platform, you have access to GPUs. We're adding support for things like Trainium and TPUs as well. And again, you don't have to change your code. You don't have to do anything. Things just run. They just run out of the box. I know it sounds crazy, but like if you've used PyTorch Lightning, you kind of know what that is. It just literally like you just say 1,000 GPUs and it just works, right? And you don't have to do anything about it. And we go all the way down to even optimizing kernels. So like if you go use our lit GPT model and then the lit llama, where you can, it's like a framework where you can load any weights from any model like Bloom or llama or whatever. You can use those frameworks to load it. All of these kernels have been fused and optimized by NVIDIA engineers on the hardware, on NVIDIA. Like the people who actually develop the hardware are fusing these kernels and making sure they're available to the open source community. So how do you think about Lightning as a company and the whole product stack? So we first start with your infrastructure. So you bring your own compute to our platform, meaning you have your own cluster, you have AWS, GCP, Azure, we don't care what it is, right? You plug it into the platform. Think about it like, I don't know, like plugging things to an outlet, right? Like a house. You just plug whatever you want in there. And then on top of that, you're going to be able to bring in the data that you want from S3, Snowflake, any integration, and we'll build custom ones if needed. And then on top of that, we layer a suite of tools, right? So anything for us that's like training, fine-tune, people ask us, can you train, can you fine-tune, can you deploy? Yes, they're all utilities for us. These are like, in my opinion, these are like calculator apps on your iPhone, right? Like we provide the iPhone. In there, you're going to provide the power. So what network are you going to use? AT&T, Verizon, whatever. That's your infrastructure, right? Your data is going to live on that device. We just make it all work together, and then we give you a set of apps on top of that let you train, fine-tune, deploy, whatever it is, right? Or you can build your own apps as well. And then on top of that, we layer a whole system of enterprise controls. RBAC, the ability for teams to work together, measure costs in real time to the second so that you don't blow your budgets. Compliance, we work with a lot of regulated companies, finance, healthcare, big tech companies as well. So we're very, very familiar with everything that needs to happen here. And I personally spent a long time working on the stuff at Goldman Sachs and a few other, like DoD and a few other regulated places. So we're very familiar with the use cases of how these things work. All of this is the Lightning platform, right? So when you log into lightning.ai and you sign up, then you'll be basically taken to the platform. Today, you're going to be put on a wait list, so email us and we'll get you off the wait list, and then you start using the platform. All of this is happening under the hood in a super, super simple way that you don't have to like think about AWS or cloud or any of this stuff, right? And under the hood, it's all powered by open source, which is, I think, the best part of this, right? Because it's all transparent, and you can actually understand what's going on, and you can see it, and you can contribute to it, and you can improve it yourself as well. So what is PyTorch Lightning? Just at a high level, for those of you who are not using it yet, here's my analogy for you. So PyTorch is to Lightning what HTML is to React, right? So when HTML came out, there weren't frameworks. There wasn't React, there wasn't Angular, there wasn't Vue, there wasn't Ember, none of these things. Everyone basically built their own little version of it internally. And that seems pretty silly today, to think that like some random company would like develop React because they need to build a web app. That's not gonna happen, right? But that's kind of the state of deep learning today, because we're coming out of this like build your own thing all the time. So PyTorch is basically that, the ability for you to build that. So pretty much, I guarantee you, every one of you who's not using Lightning today, you have built some version of it internally that kind of looks like it, but it doesn't have the thousands of people contributing to it, all the bugs that have been fixed, all the hundreds of thousands of hours that have put into it, all the engineering from NVIDIA, all the engineering from Google, all the engineering from Meta into it. You haven't done that, right? So it may look and feel like it, but it's not going to perform the same way. So that is what a framework does. It gives you the contributions from the whole community into something that you can use as a company as well. So if you want to continue building your own version of React, go for it. But when that person leaves your company, then what, right? You're not going to be able to maintain that. So it becomes a real problem. So this is what Lightning solves. You know, if you try to build like a personal web app, sure, can you do it in HTML? 100%. Are you going to be able to build Instagram using your raw HTML? No, it's not going to happen, right? So you need a framework like React. So people who tend to still stick to just kind of regular PyTorch are usually going to be individuals or people who are not working together with other people. But the second you have other people working with you, it's going to become a problem, right? And you'll notice that very quickly. So when do you use Lightning, the product and the platform? So there are 3 stages, I think, right now that you can use. So if you're going to POC and prototype stuff, like you should totally go use ChatGPT and these APIs, right? Because they're going to get you to something very quickly. Now, again, this is like startups. You want to do a POC for a product. It's probably the fastest way to get started, and you should definitely try it out. But at some point, you're going to need to fine-tune or train that model, right? You're going to make your own version from open source or something like that. That's when you start using PyTorch Lightning on the open source. And you're probably okay with just the open source. You don't even need our platform at that point. Now, at some point, your team's going to grow beyond 2, 3 people. And then you're going to run into issues around like, where's my data? How much money am I spending? Can I track the cost? What about other machines? What about moving artifacts around? What about like compliance? All these different things. Even at startups, you're going to run into this. That's when you need the platform, right? And this is kind of like, loose analogy, like the way you use GitHub for development is the way you use Lightning for AI development, right? except that you can actually have infrastructure, all of these things managed for you as well. As a startup and even as a company, pretty much none of your jobs is to manage AI infra, guaranteed, unless you're literally Google. Maybe that's it, and AWS. But no one else's job is really to do that. Like you wouldn't host and build your own GitHub. Like that's just kind of weird, right? Okay, so the platform, some of these things here. So I do want to highlight this point, enterprise grade. There are a lot of platforms out there today, especially in the last 6 months that I've launched. We've been here for at least 3 years. And we've been doing large scale training since 2019 easily, right? In 2019, when I was doing my PhD at Facebook, we were training models on 2,000 GPUs consistently, right? That was in 2019. Today, I don't even think people are doing that really unless you're at certain companies. And most of you are struggling to get 32 GPUs running at 200. That's very, very easy for us, right? We've been doing this for a long time. So as a result, it would take you a very long time to actually build a platform that's enterprise grade, because you have to first figure out how to train these models and scale and all of this. But then at some point, you need to layer in all the things that enterprises are going to need with the observability, the security, all these things. It took us a long time to do that. So it took us probably 3 years to actually get it right and to get it to a point where we can serve big banks, we can serve big tech companies and so on. So I just want to say that in terms of platforms, we are really enterprise grade, but it is built on community and it's built on open source, which is a really nice benefit that you get as well. Whereas a lot of the kind of newer platforms that are out there, they're mostly servicing other startups because it's really hard to serve actual enterprises, right? So you have to think about that when you're making these decisions as well. So on the platform, you can basically, like I said, it's like an iPhone. You can do any of these things: develop, train, deploy your data, your environment. You can work with, chain agents. You can do Langflow. All these different things are available on there as well. So it's not just about training models. It's really an end-to-end platform. So I'll talk about one of the capabilities because it's kind of become hot lately, right? And this is really about training LLMs. Like I said, training LLMs comes down to, can you scale a model across thousands of machines, and can you move the data really quickly to there? We've been doing this for a lot of years already. So you can think about what do you actually have to do there, and we do it in a way where you don't have to babysit things. So things, spike, losses get spiked, you detect them, you recover from them, nodes fail, you recover from those, optimize networking, fault tolerant, etc. Like I said, when I was at Facebook, I was training these models on my own without a team of 20 engineers, and they were training for 3-4 months at a time on 2,000 GPUs, and I was sleeping fine. I wasn't sitting there glued to my laptop monitoring these things, right? So this has already been there for many years. Foundation models, which are things that you're probably seeing around. So what are some examples of Lightning in the wild? All of Stable Diffusion is built on top of Lightning, so all those models are powered by it. Stable Diffusion XL is now using Lightning 2.0 as well. What are these guys? Yeah, so these are some of the newer models that are coming out. Hyena, I think, is going to probably overtake some of the Stable Diffusion work. So that's already all built on Lightning as well. OpenFold, so this is on the biology side. Lightning is very big in the sciences. So if you work at a big kind of pharma or life sciences, you're probably using Lightning. All of the NVIDIA services that train LLMs and huge models, they use NeMo, which is powered by Lightning. Even the largest models that AWS itself trains are powered by NeMo, which is powered by Lightning as well, right? So we're if you're going to get it to a scale that's more than one machine, probably you need Lightning at that point. Again, these are the repos you can check out, LitLlama, LitGPT. These are really super optimized for these particular model architectures. And we do this to make sure that the code is super simple, super readable, single file implementations, and they're really optimized from all the infrastructure companies as well. I already talked about this. I'll skip the code, but this is kind of how easy it is to do training. So right there at the bottom, you'd have, actually at the top, you see train on 4 GPUs. You just say device is equals 4. You choose the accelerator, and it just scales. That's it. You could literally put 1,000 in there, and that'll work. Now, how you get the 1,000 GPUs, that's on you. However, if you run on our platform, you will get them, right? So that's kind of what we solve as well. And yeah, all this people ask, oh, what about deep speed, this and that? They're all available. They're all just strategies. They're strings you change within Lightning, and they just kind of take off and work. And then Fabric, if you were kind of not using Lightning because you wanted a lot of PyTorch control, then part of it is because you likely wanted to scale your own models and you wanted to handle how sharding happens at the module level and all of that. That's what Fabric does now. So Fabric kind of looks like this, where you basically just write your own training loop now and you own it. but now you're kind of in charge of this. So like it doesn't work, it's on you. But we will definitely take care of the scaling and give you the ability to shard a model and so on. So you get a lot of these things out of the box, but you have total control, but you might also shoot yourself in the foot. So really like 5% of people need to use this, and they're literally like sitting at NVIDIA and like OpenAI mostly, right? Everyone else, 95%, you should be using Lightning Trainer. And that's it.